hurricanes begin to form over warm water near the equator. Air passing over the ocean's surface heats up and begins to rise, leaving a region of low pressure in its wake. As more air is sucked into this zone of low pressure, it in turn heats and rises, creating a powerful, twisting column of air. The giant system of swirling winds and clouds can grow hundreds of miles wide. Most systems die out when they pass over cold water, but if the ocean remains warm enough, the hurricane can make it to land, where it wreaks havoc. Storms form in the Atlantic, with the potential to hit New York. In Manhattan, the tallest of these towering constructions is One World Trade Center. The tower soars more than 1,700 feet, making it the tallest building in the Western Hemisphere. Beneath the stylish exterior, the building's skeleton contains enough steel to build 7 Eiffel Towers. Each floor shrinks by a foot, giving the tower its distinctive taper and twist, all crowned by a 408-foot spire. But the most critical part of this megastructure lies not in the clouds, but below the ground. The rock Al needs to anchor his skyscrapers is called Manhattan schist.
The rock itself is very hard.
Manhattan's schist formed 450 million years ago. A tectonic collision between what is now the east coast of North America and the coast of Africa pushed a 15-mile-long layer of shale deep into the earth. Heat in the Earth's core and pressure from the mountains above slowly cooked the shale, transforming it into hard schist rock. Over millions of years, as the mountains above were worn away, the schist gradually reached the surface, creating the perfect bedrock to anchor a city of skyscrapers. But more secrets to the tower's strength are hidden inside the structure. A giant core of steel-reinforced concrete runs the length of the building, providing firm support for each of the 104 floors. Below ground, 80-foot-long steel anchors tie the building into the schist. The foundations extend 20 feet into the rock, creating a solid, stable platform for the building. The twisted and tapered frame has an aerodynamic shape, designed to break up and deflect winds of up to 150 miles per hour. With tough steel skeletons, concrete cores, and foundations set deep into Manhattan's hard schist rock, New York skyscrapers are designed to survive the largest Atlantic hurricanes and keep the people inside them safe. But when a superstorm strikes, destructive winds attack one of the city's structures before any other. 2 concrete decks span 1¼ miles, one stacked on top of the other. The roadway is held aloft and kept stable by pillars almost 700 feet tall that extend 150 feet into the channel. The bridge forms a vital artery for the city, but its position spanning the main sea strait into New York Bay puts it at the mercy of North Atlantic superstorms. Replace the heavy concrete upper deck with a much lighter one. It's made from 2 layers of steel beams. One layer runs parallel with the traffic, the other perpendicular to it. This design helps to spread the weight of the cars evenly across the entire deck. It's also much stronger. Stiffening trusses along the length of the bridge secure the upper deck to the lower roadway, forming a single rigid structure that can move from side to side in strong gusts, while keeping New York's drivers safe. A systematic failure of the New York subway could strand millions of commuters and bring the city to a standstill.
The MTA will suspend bus, subway, and commuter rail service.
Hub of New York's vast rail and subway network, Grand Central Station was one of the first steel frame buildings in New York. Its walls conceal a vast system of ramps and stairs which shuttle commuters down to 44 mainline and subway platforms. In the early 1900s, miners dug through soft clay to create the earliest subway lines 20 feet deep. As technology evolved, engineers cut additional tunnels through the solid Manhattan schist, creating a rabbit warren of more than 100 miles of underground tracks. But superstorms are increasingly threatening the entire system. Hurricane Sandy crippled the city's subway networks. They can record the level of the water table. When the water table and the subway are at the same level, major complications can result. Manhattan lies just above sea level. As the city has grown, the subway has also been extended. Sitting 20 feet beneath the city, they now snake their way under the prime real estate at the water's edge. Tunnel entrances close to the harbor are in the heart of the danger zone. When a superstorm strikes, the tunnels act like enormous drain pipes, channeling floodwater into the subway network.
It's always been a battle of the coastline.
18 stories below Grand Central Terminal, a massive engineering project to upgrade New York subway is underway. This is East Side Access, the largest transportation project in America. More than a mile of new tunnels and caverns 65 feet high will connect Long Island with the iconic station. This team of engineers are testing a clever invention that could provide a solution. A giant subway tunnel plug. To prepare for the worst-case scenario, they will install these plugs at strategically placed flood choke points in the network. When a storm strikes, the plug inflates in less than 30 minutes. Wider than the tunnel, it's capable of expanding into every gap. Its skin is made of 3 layers. A soft, airtight inner layer is covered by tough polyfibers, and finally a tear-proof mesh of woven fibers on the outside. Together, they create a watertight barrier to incoming floodwater, allowing subway commuters to travel safely in and out of the city, whatever the weather. Ongoing battle as New York's subway network continues to grow. There are thought to be over 600 different ways water can flood into the Manhattan subway system. Sealing all of these gaps is a daunting task, but New York's engineers are devising innovative ways of making this a reality. A single major storm like Sandy can knock out the power to millions in an instant. The most unusual network is a 105-mile system of tubes that pump 400-degree steam at 75 miles an hour. Over 2,000 office buildings and hospitals in Manhattan use it for heating, and 7 power stations pump out more than 13 million pounds of steam every hour to keep New Yorkers warm and dry. The schist bedrock that holds Manhattan skyscrapers steady has a weakness. It's full of cracks. Groundwater runs through these fractures, creating a subterranean network of rivers. storms cause the river's water level to rise, swamping subterranean structures like the steam network, which causes huge problems for New York's engineers and puts the city's residents at risk. Hitting the outside of hot pipes causes an effect known as water hammer. This can cause pipes to weaken and can trigger a catastrophic explosion. To avoid these street-level blasts, engineers have created a water-level alarm. The water alarm is placed beneath the manhole. At the heart of the device, a float sits just beside the steam pipes. If the water level in the ground rises, it lifts the float. The rising float then triggers a switch that sends a warning signal to the control center. The higher the float rises, the more frequent the alerts become, allowing engineers to shut off the steam supply before it explodes. Innovations like this will help protect New York's vast steam network against future storms. Keeping Manhattan's most famous residents heated through the cold and wet storm season. New York and New Jersey Port is the epicenter of maritime trade on America's East Coast, radiating out from the Statue of Liberty for 25 miles. As the USA's third largest port, it's a major destination for cargo ships from around the globe. At its heart lies New York Harbor. At 5.5 miles wide and more than 40 feet deep, it's one of the biggest natural harbors in the world. But keeping this vast gateway open for business is a tough job when superstorms like Sandy strike. The storm blocked channels and damaged docks, stranding petroleum ships and coal barges out at sea and causing major fuel shortages. The harbour was formed over 22,000 years ago, when the planet was in the grip of an ice age. A vast glacier 3 times the height of the Empire State Building covered half of North America. As the glacier moved south, its monstrous mass churned up the ground, pushing forward a huge wall of debris. When the glacier eventually receded, it left behind lakes full of ice and meltwater in its wake. One of these lakes formed where the Hudson River lies today. As more ice melted, a surge of water burst its southernmost bank, connecting the lake with the Atlantic Ocean and creating New York Harbor. Today, mud chokes the area, leaving supertankers struggling to squeeze through the shallow waters. With a natural depth of only 17 feet, engineers must work constantly to keep them open. 35 miles of critical shipping channels must be dug to a depth of 50 feet. The excess spoil from the deepening project is used to repair the ravaged coastline before the next storm season rolls in.
To provide flood protection.
This will help slow the next incoming storm, but they won't be enough to stop it. Predicted Sandy's devastating effect, and is convinced the next big superstorm is on its way.
People ask me, how ready now is New York for the next storm? I don't think it's really ready at all. I think the city is completely